too much about this with regular math because you just know these things. With
She made it!
oh, now your best friend said you would have been here on time if your legs were longer.
Wait, what? Wait, he made that up. That's what he was thinking the whole time.
Would I make that up, or would that be something she would say?
That's something Tanisha would say, honestly.
What? Yeah, what did I say?
Didn't you say that? You can go on the video later and then rewind, and it's gonna be there. Okay, so with regular math, we have multiplication being commutative. You don't use that word very often, right? Like 5 times 3 is the same as 3 times 5. I don't know when you learn this, but it is very fun if you have a little cousin, when they're just learning multiplication, to do something like, what's 2 times 7? And you like they're process, they're adding 2 7s, 14. And then right after you, okay, what's 7 times 2? And they will process for just as long. Because they don't know yet that 2 times 7 and 7 times 2 are the same. Because for them, 2 times 7 is 2 7s. And 7 times 2 is 7 2s, and they do them separately. Right? Somewhere along the line, you learn this. But in matrices, it does not work. You can't. Oh, I did a whole bunch of mathematical experiments on Bryn when she was little. Explained a few things, right? Anyways. But multiplication is associative. So if you have 3 things, 3 matrices that you're trying to multiply together, you could choose to multiply A times B first and then C, or you could choose to multiply the B times C first, then the A. And you can distribute in matrices. I don't know really why you would want to distribute, because think about it this way. If you distribute, you have to do matrix multiplication here once, and matrix multiplication there twice. Do you remember how hard adding was? Oh, I know. And then you would have to, if you added first, then you'd have to multiply once. If you distribute, you have to multiply twice. And the multiplication, that's where you like turn them sideways, crash into each other, add up the pieces. That was a lot more complicated. And we're going to learn that there is a multiplicative identity. The identity matrix, which we had in our notes before. It is a square matrix with 1s along the diagonal. So this would be a 3 by 3 identity matrix. And if you multiply anything by the identity matrix, it keeps things the same. Right. We did multiplication yesterday. Let's do, here's my 3 by 3. Okay? This is a 3 by 3, so I could multiply a 2 by 3 by that, right? Because then my middle numbers would be the same. That would allow me to multiply. So if I did 1, 2, 3, 4, 5, 6, and I would end up, my answer would be outside numbers, a 2 by 3. And if I wanted to find first row, first column, I would take first row, first column, turn it on its side, crash it into there. And notice only the 1s would hit. The 0s would go away, and you would get 1. If I took this one, row 1, column 2, turn this on its side and crash into it, you see that only the 2 would hit the 1. And I would get a 2. Similarly, let's just do the 6. So the 6 here, that is row 2, column 3, turn it on its side and crash into it. Sure enough, you would only get the 6. So having a matrix with diagonals of 1 and everything else 0, when you multiply by that, you get the identity matrix. And there exists an inverse for matrices, so that if you take A and multiply by the inverse, you get the identity matrix. And that's where we're going to do a bunch of math later on, is with matrix inverses. There is no such thing as dividing in matrices. There's only multiplication. Today, we're going to look at how you can use matrices to solve problems that you could solve without matrices if you wanted to, but the matrices might provide a nice way of organizing your data and solving. Matrices are helpful when you have large amounts of data and you want to solve stuff. So here's a sports company. They have balls, bats, and gloves, and they send them off to sporting stores. And here are 4 stores, P, Q, R, and S, that have ordered things: balls, bats, and gloves. Okay? What we're going to do is we are going to make a matrix. Sometimes a short way to make the matrix in your notes is like, I'm just going to call this matrix A by doing that, without rewriting everything. But I did rewrite it. It's there for you, if you're one. There's our matrix A. How big is it? It has 4 rows and 3 columns. And in word problems, not only are we going to think about the dimensions, but we're going to think about the dimensions in terms of what they stand for. So this is balls. I should have sold something other than balls and bats because they both use B. And you can't even use the second letter to distinguish them because they both have an A as a second letter. So this is balls, then bats, then gloves. And it's going to be important, the order that we use. Because we're going to use matrix multiplication. And in matrices, you can multiply things together and get answers that make absolutely no sense whatsoever. Or we can multiply things together and have answers that make sense. But it's going to be that not only when we multiply, you know how when we multiply, like we are going to multiply this by a 3 by 1, which is totally allowed because the middle numbers match up. But the middle numbers need to match up and match up to be the same thing. So in part B, here, it says, write cost per item as a column matrix. And it's very important that when we do our cost one, that the 3 is in the same order as the 3 on our other one. So notice how we had balls first, then bats, then gloves. In my cost matrix, balls cost 8, bats cost 30, gloves cost 75. I'm making this in the same order that I had before. And I'd like you to take those and put them into your calculator. So we can go to our calculator, go second matrix, edit matrix A, and now we have a 4 by 3. And you can just type over the numbers. 70, 30, 22, 60, 20, 19, 7, 15, 24, and 50, 40, and we're going to edit matrix B and make it a 3 by 1. And 8, 30, and 75. Now, you get hired by the Burgess Sporting Company as their person who does some account stuff. They're like, you did well in math, I saw you took AP Calculus, so we want to hire you to, these are the orders, this is how much we charge, you need to send a bill to the different stores. Could you do that? Absolutely. You have the math skills to do that. How much would you charge store P? Well, you would take the 70, right? And you multiply it by $8, because it costs $8 for each of the balls. You would take the 30 and multiply it by 30, and you would take the 75 and multiply it by 22, and you would send them their bill. And you could do that completely without having matrices. But I'm going to show you the nice thing about matrices is we have our matrix A, which is a 4 by 3. And in that 4 by 3, this one was P, Q, R, and S, and this was ball, bats, and gloves. And then we had a matrix B, which was a 3 by 1, which was also balls, bats, and gloves. This, very importantly, is the exact same as this. Not only is the number the same, but the items are listed in the same order. Very important. And the 1 was the cost, which I'm going to just put as a dollar sign. If you multiply those together, matrix multiplication says you are allowed to do that. I can go to my calculator right now, and I can go, second quit, I can do A times B, but I cannot do B times A. I can go second matrix A times second matrix B, slide it over, and I get this answer. What does this answer mean? This answer that I have, drag it over here, maybe not. The answer that I have, oh, good. You know that your answer here is how big? A 4 by 1, because that's your outside dimensions. Your answers, when you multiply, is always your outside dimensions. But your outside, what did it stand for? It stood for P, Q, R, and S. And that stood for your dollar sign or your cost. Now you have the total cost of all 4 stores instantaneously. Kind of nice, kind of a benefit of matrices. You could figure out that all individually with your calculator, right? You could have done 70 times 8 plus 30 times 30 plus 22 times 75. But notice that when I took row 1 and multiplied it by column 1, each of those things crash into each other at the right spot, and then you could add it up and get your total. So now we see, oh, this weird idea for matrix multiplication actually has an application if we're dealing with data like this. So that's what we did. We took our matrix, we multiplied them together, and we got a new matrix, which each of the stores and their cost. And the other thing you can do on your calculator is once you get an answer as a matrix, you can use your store button. I can go second matrix. I can go down to C. And now that puts all that numbers into matrix C for me. Part D, you have to add a shipping cost of 1.0 or 2%. So each of these has to add 2% to it. And you see that you could do that by just taking 1.02 and multiplying it by matrix C. That's scalar multiplication. That 1.02 out in front will multiply to each one on its own. Push enter here, and that just added 2% to each of them. And it says create a matrix D, so I'm going to take that matrix that I just made, I'm going to store it as matrix D. Now, most companies will not be getting you to use your graphing calculator to do this, but it might be in their computer programming software in the background that their computer program may be using matrices or a similar thing with spreadsheets to do this data instantaneously for you, right? So the company you're working for has paid another company to develop that computer science and that software. So some of you might be going on to study computer science. Why is mathematics used so much in computer science? Because they're using a lot of these mathematical skills to build the programs for companies so that the company can easily do what they want to do without having to know the math in the background. Right? They pay somebody else to do that for them. At the end of the day, they're always paying someone who knows math to do something for them in the end. What is the total amount owed to Burgess by each store? Well, we figured that out. That was our matrix D after and if you wanted to add these all up, you could just add them all up. That's not hard. You could use matrices to add them all up. If you took this one, which happens to be a 4 rows by 1, and I wanted a total, I could multiply it by a 1 by 4 with all ones. That ones would turn on its side, crash into there, take each of them once and add them all up. And I could get the total that way. Sometimes though, you might just decide to add them all up. Okay? So this is still, there's one store of P, one store of Q, one store of R, one store of S. The number of stores, because it could be that maybe store P is Sport Check. That's P, right? So I said the P extra loud there. But there's 20 Sport Check stores that are all ordering the same thing. So here I made how many Sport Check stores? I don't know why Qdoba is ordering baseball bats, but maybe. These could be the different stores, and this is the number of stores. So you make the total number of money in the end is your 1 by 1. And they're getting $11,143. But if all of a sudden you had 3 of store P, 2 of store R, and 4 of store S, and you wanted to know the total, you could make another matrix that said how many stores of each one you had, and can multiply them together. The next question I made pre-COVID. I'm sorry, I caused COVID. The virus hit the school. Again, to make our life quicker, oh look, Nurse Bertha discovers that students are either sick, well, or carriers of the virus, right? That happened with COVID, right? There's some people that got sick, some people that were fine, and some people that were fine, but they had the virus. It's like, oh, they went on, coughed on you, and you're like, what are you doing? And so we have the following percentages. That in grade 11, 15% are well, 35% are sick, but 50% are carriers. In grade 12, 25% are well, 40% are sick, and 35% are carriers. So I put brackets around that. I'm going to make that my matrix A. Here's the population distribution by class and gender for grade 11 and grade 12. I'm going to make that B. And I notice that when I have these matrices together, these match up, not only in size, but what they represent. So I can very quickly use matrix multiplication to answer the questions that come after. So I'd like you to put those matrices into your calculator. What are you going to do with the percentages? Probably change them to decimals. And I want you to use your calculator to answer the questions on the back. Wait, how did you do? Did you get this matrix in the top right when you multiply them together? And again, these questions, how many males are sick? Given this data and your ability, you could figure that out, okay? But notice how by multiplying the matrices together, when I multiply A times B, I get well, sick carrier, that's what that 3 stood for, males and females, and now I have data that's really quick to get it from. How many males are sick? 79. It's that quick, right? Otherwise you'd be like, oh, okay, I have to take this data and this percentage and multiply. How many females are well? Well, females, 38 in the red circle. And how many females are carriers? 76. And we can get those answers quickly with our matrices. So anytime you make a matrix, there's a little bit of planning on how you make it, right? Like I could have had, and there's going to be questions where they just give you data and they don't give it to you in a chart. You could make the chart with the males and females here in the grade 11 and grade 12 there, but then you wouldn't be able to multiply them together to mean anything. So not only does multiplication require that the numbers are the same in the middle, but when you're dealing with a word problem, those numbers have to represent the same things.
For like the 38,
Yeah.
rounded up, is it okay to round down to say how many people? There's not 0.75 on
Yeah.
this.
Good. Yeah. So
Does it matter which way you round?
it does.
With
Okay. And you might want to just make a little note. I rounded up, or I rounded down to the nearest number. Yeah, you can't have half a person. They're like, I'm mostly okay, but I'm partially sick. Right? Just my foot, right foot, is sick. It's probably going to spread, but I'm mostly okay. I'm that 0.1 person or whatever. Did you see the next example? Like, when did we have to read a novel for math class? There is a bunch of information just given to you. You have to organize that into a matrix. There's 4 models: the budget, the economy, the executive, and the presidential stereo. And the budget model needs 50 transistors, 30 capacitors, 7 connectors, and 3 diodes. But if you go up to the presidential model, there's 85 transistors. So we need to make a matrix that organizes all of this data. So I put it this way. The first matrix, it really doesn't matter. If you put the beep along the side, or the beep along the top, you're going to be people watching this video and think that I was swearing and it got beeped out.
I'm gonna make a comment on
You're going to make a comment on that? There shouldn't be swears in math class. But how you make your first matrix depends on what you're going to do for your second matrix. For my second matrix, now I'm going to put the beep across the top, so that it matches up with the beep that went down on the other. Because here in my 4x4, right, this 4 is rows, this 4 is the beep, and this is the pepper cone.
Oh my gosh, I just understood it. I just understood why you're beeping.
Kaizen, would you like to make a comment?
No.
No comment. And then this 4 would be the beep. You thought I actually wanted to swear?
I was like, why are you beeping? I was like, oh. See?
Oh, wow.
I thought you just didn't want to say the word. I thought you just didn't want to list them all out to beeping instead. Yeah.
Oh.
That makes sense. You put the beep, and I'm like, the beep? Why is it beep?
Okay. That's good. That's good.
That's your daughter.
Now, did you laugh at her when she said I just got it? You did, and you hadn't got it yet. Yeah, I saw that.
No, because I thought the thing we were getting was that you were like beeping because you didn't want to say the thing. I didn't realize it was an acronym or whatever.
Yeah, that's amazing.
The word with the sound.
Oxymoron.
No.
I think you got the last part of that right. Wait,
The other thing, he asked me what a bird was.
I think the onomatopoeia.
Hey, to be fair, Dennis didn't even know what a verb was.
You're still like the ball.
That's right.
I don't know what a bird is.
Steve, do you know what a verb is?
Yeah.
Do you know what a verb is?
A doing word. See? Action word.
So if we stored this data into matrix A and made this our matrix B, I specifically made matrix B into a row matrix because I needed my beep to be second to match up with the other beep. And then when you multiply them together, your middles are the same and they stand for the same thing. So then what was our outside? Our outside one was per day, and the other one was transistors, capacitors, connectors, and dials. So now we have a per day of how many things are needed. So this could be helpful if you're on the ordering. You're in charge of ordering transistors, capacitors, connectors, and dials for the company that's making these. Now you know how many you need to order per day. Could have been figured out with individual math, but the matrices just make this nice and quick to solve. So now we can answer these questions. How many capacitors are needed each day? That we've got right here at the bottom. So I don't know if you wrote that down already, but you can write that down for that question. And I would probably take that matrix, because I might need it later, and store it as matrix C. So each time you get a new matrix, you can store it as something else. And you can look at your matrices and say, oh, which of my matrices can I multiply together and get new matrices and get all sorts of data quickly that you can use for other items. So during August, September, production is increased by 40%. How many presidential, executive, how many of the beep models were each produced? So what would we look at? We make a new matrix D. It's going to be the 1.4 times matrix B, which was this one right here. You had 10, 12, and 11, and 7. That's how many you were making per day regularly. Now, we're going to multiply that by 1.4. And now this is how many we're making per day. I guess depending on the company, the decimals may or may not make sense, right? Maybe the company just says, it's 5 p.m., shut down the machines. It's okay that we're done 0.8 of 1, we'll just start that the next day and finish it. I can see that happening in a lot of bigger manufacturing. It's like you're building a brand new car, you didn't quite get done in a day. It's not like, oh, throw that one away, start again tomorrow. You just start where you left off. So again, we can take our matrix, get a new matrix. Five person hours to produce the budget model. You like that word, person hours? It means it takes one person 5 hours. It takes one person 5 hours to produce the budget model, or it takes 5 people 1 hour. Depends on how many people you're working. It's going to take 5 hours to produce the budget. So now we have a choice. We can either make hours with beep as a row matrix or hours with beep as a column matrix. And we need to figure out the number of employees. If everybody works an average of 7 hours per day, how many employees are needed in August and September? Well, we already had, this would be in a regular day, regular month B times E, you need 249 hours. Total, divide by 7 hours, you're going to need 35, almost 36 employees. In a regular one. In August and September, you would have to do D times E, which is going to be the same thing, but is going to, what did we do for D? Our D, multiply that by 1.4, so normally you would need 35 employees.
So can I please have John and Blake Burbuck to the office?
Yeah, they'll be right down.
Yeah. Can I go now?
Yep.